So let's go ahead and get started with showing you what this looks like in action by building a custom root file system using the Jetson Containers project with Visual Studio Code and the Windows subsystem for Linux. So first what we're going to do is head on over to the Jetson Containers project. And as I mentioned, this project is fully open source, maintained by Ian Davis of Microsoft. And if you head over here, there is a lengthy guide here that can help you get started with using Jetson Containers. I'm actually going to follow along with an article that we published to Dev2, and this will be as part of the resources that we'll give at the end of the session. But we're essentially going to follow through what's contained in this particular article to go through a demonstration of what you can actually accomplish with the Jetson Containers project. Now, I've already installed the Windows subsystem for Linux, and I've got this project open on my Visual Studio Code instance. And the first thing we're going to do is from within a WSL terminal, I'm going to go ahead and start the Docker runtime. So we'll go ahead and start Docker, and I'm also going to start binfmt support. This is going to allow us to be able to build ARM packages from the x64 environment that I'm currently running my Windows operating system on. Now, once we have those two things kicked off, I can go ahead and hit Control-Shift-B, and that's going to give me a number of tasks that are sort of built into this project, and makes it very, very easy to almost pick and choose exactly what you need when wanting to build either self-contained container images or a custom root file system. So let's start by showing how we can build a container that contains all of those CUDA dependencies. So I'm going to go ahead and select this Make Jetpack Dependencies, and we'll choose the Nano Jetpack 4.2.2 option here. Now, I've already brought the NVIDIA SDK Manager into my WSL environment. That is something you would need to do up front, but you'll see we're actually invoking that with the CLI option, and it's going to ask me to log in with an account. So you will need to have an active NVIDIA developer account in order to use this. Once I've logged in, it's going to go ahead and kick off an instance of that SDK Manager. And you're going to see here in just a few moments, it's going to give me all of the options to be able to choose whatever dependencies I'd like to package into my container. For example, do I want the Jetson OS, or do I want the CUDA drivers, or various other different software, for example, TensorRT and things like that. Once I've got those selected, I can go ahead and hit Enter, and that will submit my selection, and it's going to go ahead and download those dependencies from NVIDIA. Now, the next step that this is going to do, once it's got all of those, is it's going to kick off a build to the Docker daemon. And this is going to actually use those binfmt tools as part of that process to build an ARM64 based container image that contains all of the CUDA dependencies for that Jetson Nano device utilizing Docker on my x64 machine. So I am benefiting a little bit here from having built this before, so it's going to send that context over, and we should benefit from having some Docker cache available on the machine, so this build would go a bit faster than you would normally expect it, but depending on what dependencies you're bringing in and how large your ultimate image is going to be, depends on how long this build will eventually take. So there we go. We've successfully created that image, and it's been tagged as L4T 32.21 Nano Jetpack -4.2.2-deps. And that is a full container image that contains all of those CUDA dependencies. So if I wanted to add a userland application on top of it that took advantage of it, I'd simply create a Docker file, and I would use this particular image, and then I would add my userland application on top of that. Now, what if I wanted to build a custom RootFS that we might want to flash to devices? There's a few flavors that are offered here, one of which is the Bionic base. So I'm going to go ahead and select that. And this is going to go ahead and pull down that latest CD image of the latest Ubuntu release. And then it's going to use a dev bootstrap process to go ahead and kick off a build of that root file system. And so the end result here is that I have a container that contains a flashable image that we can pull out, and provided I had a USB connection to a Linux OS and a applicable Jetson device, for example, a Jetson Nano or a Jetson Xavier, I could then shoot that image over to that device and flash it with that newly created production image. Of course, if you are looking for more information about the Jetson Containers project or links to those articles that we had shown that will demonstrate how to use it, you can head to aka.ms/Jetson-containers to find all of the resources applicable to this portion of the presentation.